Hey, Donovan Keith here. I'm the product manager for capsules at Maxon, and in this video I want to talk through how you might use scene nodes to create a parametric door handle like you see here. I've got the ability to adjust the width, the height, the depth. There's a rounding control. I can adjust how these are aligned. And I've already got some symmetry on here, so I can turn that off, and you'll see that you can also mirror this on the x-axis and sort of create your own custom door handle in this way. So let me talk through the overall structure and how it's sort of functioning. We may not implement all of these features in this video, but I'll give you a sense of basically what's going on. So if I open up my door handle setup right here, I've got a build array, which I'm using to build the overall structure of this handle as though there was no rounding. So I'm starting here, moving out, moving over, moving up, moving in, moving back. And I'm doing all of this with just ones and zeros. So I'm either moving out or back or whatever that is, just using unit values. And then I am multiplying every single one of these points by the width and height that we're getting from the user here. And that's just a simpler way of structuring these things sometimes. If you just kind of build them to a unit box, you can then scale them. I'm then doing a bit of trickery here to remove duplicate points. So if I've got 2 points that are right on top of each other for width and height, I am removing those. And then I am doing a little bit of tweaking of the Y position of all of my points based on whether or not I've turned on an Align Y checkbox. And then I am building a spline, and then the rounding is being handled by the spline chamfer node. The actual handle itself is being built with a sweep inside of the objects manager in Cinema 4D. So let's go ahead and build this from scratch, or some version of this. So go ahead and create a new project file. And I just want to walk through what we're going to do, and let's do it manually first. Sometimes it's easiest if you build a thing in a more traditional workflow before you go in and build it procedurally. It helps you plan out what you're doing. So I'm going to go into my modeling settings. I'm turning on snapping. I'm turning on grid work plane and guides. And I've got my spline pen tool. And my first point is going to be at the origin. My next point is kind of be 1 unit out from here. And then I'm going to go over, and then I'm going to go up a unit, and then I'm going to go over, and then I'm going to go back. And let's hit escape. So this is really what we're trying to build procedurally, is this sort of like 2/3 of a box. And if I turn on my my point indexes, you'll see what this is sort of doing. So this point right here, let me go to my object mode, has got a position of, let's say, 0, 0, 0. This point right here, it's going this way in z, which is actually negative z. So it's -1 on z, and then it's 0 on y, 0 on x. This one over here is moving over on x, so it's, 1. It's not moved up yet, but it's still back this way, so -1 on z. Now we're going up 1, so this one is going to be 1, now moving up the 1, and still got this negative positioning. This one over here is still lined up 0 on x, so that's 0 on x. The y value is the same as this one over here, 1. And the next one over here, we are sort of back on z. That's -1. And then this point right here is basically at the origin but up. So it's 0 on x, 1 on y, and 0 on z. So this is the rough plan of what we're going to build first thing. And once we've got that built, we can go from there. And let's see. We can probably give these different names, or we can just use the point over order. Let's go ahead and add a nodes spline. I've double-clicked, I've hit Shift-C on my keyboard to bring up my commander to search for the node spline. And now I'm going to go to my nodes layout here. And in my node spline, we're about to add some things. I'm going to hide my console so it's a little bit easier to see what's going on. I guess I don't want to rotate my view because I want to keep this sort of lined up. And with my node spline, I'm now going to add an assemble spline. And the assemble spline is looking for a number of points, some segments and tangents, and I want this to be hard to start, so I'm just going to choose linear for my type. I'm going to wire out my geometry here. So now we are building an empty spline. And right here we see that we need some points, and it's looking for an array of vectors, or an array of points. And to create that, I'm going to use a build array. And the build array, I'm going to change its type to vector, and I'm going to wire out my output here. And I'm just going to build this up one at a time. So I'm going to delete all of these points, and then I'm going to start by adding them one at a time, and we'll just sort of map these values right here. So 0, 0, 0 for the first. The next one is 0, 0, minus 1, 0, 0, minus 1. I'm going to add another point. We see it's 1, comma 0, comma minus 1. We're going to add another point. This next one is 1, comma 1, comma minus 1. The next one after that is this guy right here, 0, 1, minus 1. And the last point right here is 0, 1, 0. So let's call this unit points. I'm hitting command / to edit my comment there. And now that I've got these points, I'm going to hide my doodle. I'm going to hide this other spline, and let's hit the H key or the S key and sort of frame this up. And we can see that, oh yeah, this looks a lot like what we had before. We've got this nice tight configuration. So what I want to do is scale these points by a width, height, and depth that the user sets. So to make that possible, I'm going to add 3 inputs. IO size. I'm going to drag this first one. Size, size, size. Width, height, depth. And I'm going to, while we're at it, I'm going to add a rounding parameter as well. IO size. To add our rounding, because we know we're going to use that later. And now I want to edit the defaults for all of these to something a little bit more sane. So I'm going to right-click in here and choose Edit Resource, which will bring up my resource editor. For all of these, I'm going to set the maximum to, let's say, 50, because I don't think we're really going to need much more than that. Let's start with a default value of 10 for all of them, and then tailor from there. So width, let's say the default value is 20. Height, the default value is 40. Depth, let's set it to 15. And rounding, let's set it to 5. These feel like they'll probably be pretty good values. We'll probably tweak these later, but this will give us a good starting point. Now, we've got all of these unit points, right? They're all sort of aligned to 0 or 1 or minus 1. And what we want to do is use the width, height, and depth to feed them. Now, if we wanted, we could go in here and say, oh, element 2, it's minus 1 for depth. And I could bring out my depth, and I could add a negate, and I could wire it directly in here. But again, I think it's just much simpler to work with these unit values and then scale the result. So now I'm going to choose Scalar Arithmetic, which allows me to work on every single element in a list or an array like this. I'm going to drag it onto the wire. Now we're getting an error because it's saying no conversion possible. So when I hear no conversion, that's usually about a type, and I want to change the data type here to vector so that the type here and the type here match. And now for my scalar here, my XYZ, width, height, depth. Now, this is not what we wanted. Everything is now just sort of been shifted up quite a bit in size. It's all the way up here. So we don't want to add, but what we want to do is multiply. And now we have got this handle that has got the right basic configuration to be a handle here. So now that this is assembled, I want to round it. So I'm going to add a spline chamfer. This is going to allow me to round a certain distance. So I'm going to command click on distance here to expose it, or control click. And I'm going to connect my rounding value here. Now, I can come in here and I can adjust my amount of rounding, but you might notice that it looks a little bit funky. It doesn't seem super round. And that's because our node spline, by default, if you go to the subdivision tab, is going to be of type linear. If you change this to Bezier, you'll get a better result. Now we're getting a bunch of points here from that sort of soft subdivision. So I'm going to turn off my point indexes. I'm going to turn off my polygon indexes. And now we've got our handle. And if we want to just give that some thickness, we can do that in Cinema 4D with or in our Objects Manager with a sweep and a profile spline. So just a circle. Let's make this, I don't know, 2 centimeters. And now we've got our handle. We can click on our node spline. We can adjust our width, our height, our depth. And it all works out pretty well until you get to these scenarios where you've got points that are overlapping each other. And what I want to do is remove my overlapping points before I build my spline. So this is going to get a little bit trickier, and I would say that, unless you really plan on redistributing this to other people, this is probably a good enough solution for most production use cases. So what I'm about to dive into is going to be a little bit more complex, but this is the sort of thing that you might want to do if you want to make something that's a bit more foolproof to hand off to someone else. So what I want to do is look at all of the points that I have here. And you know what? I'm going to save my project because that's usually a good thing to do. But I don't want to show, you know what? I'm going to play a little bit risky because I don't want to show it's on my desktop. I've got some work in progress. So what I'm going to do is just take a look at this right here. I want to make sure that my node spline is selected. I'm going to select this port and then choose Data Inspector. And we now see the values here. And if I take my node spline and I set my width to, for example, 0, what we're going to notice is that some of our points now hold the same position. This point and this point, 1 and 2 are the same. This point and this point are the same. So what I want to do is go through each of my points, and I want to say, hey, are you the same as the previous point? If not, go ahead and stick around. If you are the same, we're going to get rid of you. So this one, so to sort of mimic that, the previous point, well, that doesn't exist, so you're different from that, so we keep you. Are you the same as the previous point? Nope, so we keep you. Are you the same as the previous point? Yes, you are, so we're going to get rid of you. Are you the same as the previous point? Nope, so we're going to keep you. Are you the same as the previous point? Yes, so we're going to get rid of you. And so on and so forth. So that's the procedure we're going to go through. And to do that, we're going to use something called an iterate collection. So iterate collection, you can drag onto any sort of wire that's got these sort of like 4 squares, an array type. Oh, at least I thought you could. We can at least drag the collection right onto here. And now this is going through every single point in our collection here. So what I want to do is rebuild these. So we're going to go through and we're going to build a new array from scratch based on whether or not we want to keep a given point. So now I'm going to add what's called the loop carried value node. And in another video, I go into this in a lot more depth. I'm going to change, well, we can keep this first point here. I'm going to call this previous point. I'm going to add another new input. I'm going to change the type here, so it's structure array. I'm going to come in here. I'm going to replace basic vector. So now we've got an array of vectors or points. And I want to initialize both of these with a starting value. So I'm going to add a value here for my vector. And this is going to be starting point. And I'm just going to punch in all minus values, -1, -1, -1, because I know that this is not one of the point values that we're going to run into. So that's a safe starting value for previous point. It's not going to be a duplicate. And then for my points here, I'm going to choose to build an array of vectors and just get rid of all of these. So it's an empty collection to start, and I'm going to wire this in. And I'm going to wire the result of all of this into my assemble spline. I'm going to take my scope port for my iterate collection, which is saying do this, do this, do this, do this. It's just sort of a tick for updating. I'm going to connect those. And I'm going to wire in this point that I want to work with. So I'm going to call this current point. And I guess letters are cheap. Previous point. Let's just call that previous point. Now, we're getting an error because it's saying there's some issue with the loop carried value. And for me, that's because we haven't really connected the output to the input. So if we want, we could just directly wire points to points, and then that would sort of fix that error. But it hasn't really solved our problem. What we want is for every single loop, every single point that we go through, to update for the next go round the previous point to be the current point. So I'm going to wire current point into previous point. And then points, we want to build this up over time. And so what I want to test is, hey, is the current point the same as the previous point? If so, don't add it. So I'm going to do a distance between these 2 points. And I want to see if you are less than. And here I want to just put in sort of my welding value, 0.001, something small like that. And I can output this if I want and call it tolerance. So you've got a clear sense of what this value is doing. So if dist is less than tolerance, do something. If not, do something else. So if the distance is less than tolerance, is same point. And I want to keep it if it is not the same point. So I'm going to choose not. So is the distance between the previous point and the current point less than tolerance value? That's going to mean they're the same point, quote unquote. We don't want to keep those. So now I'm going to use append elements. And what append elements lets me do is take an array or my list and choose what value I want to add to it. So that's my current point. I want to add my current point, but I don't always want to do that. And so to handle the I don't want to do that always part of this, I can expose this count parameter. So by default, we're going to be appending or adding the current point just once. But if we use this Boolean value, right, like not the same point. So if it's not the same point, this will be true, which will be a value of 1, which piped into our count means we will append it. If it is, if they are the same point, then the count will be, this will be false, count will be 0, and we won't append that. So let's take the append elements here, drop it onto points, and all of a sudden we've got this section here, which is a little bit tricky, as I think we sort of talked about, but this is remove, whoops, excuse me. I'm going to just say that this is remove duplicates. So now I'm building my unit points. I'm resizing them. I'm removing duplicates. So if points are overlapping, remove duplicates for better rounding results. We're building up our spline, and then we're doing our chamfer. So if I adjust my width, this is now giving us a better and more expected reaction here. So we've got our width, we've got our height, we've got our rounding. If we want, we can add a thing like a mirror on X, right? We want to flip this handle horizontally. So if I do that, I'm going to add an if. So if mirror X, I can just take this checkbox, output it, and say mirror X. And what I want is I want to use my width in the false value, and I will choose negate So the negative of this width if mirror x is true. And just pipe that into the x size here. So we've now got our unit values. This is our mirror x. So if I turn on mirror x, the handle flips left or right. We can adjust our height, our width, our depth, our rounding amount. And what we can also say is, yeah, this all works very nicely. There's a little thing that will crop up here if your rounding is set to 0. And basically that's because we've got a linear spline here that's being converted to a Bezier spline. If you really want to fix that, what we can do, and let's go ahead and fix it. Let's do the thing correctly. I'm going to change this from assembling a linear spline to assembling a Bezier spline. And I'm going to fill an array of hard tangents. So I want to get my count of points right here. And then I want to do a fill array. The length, or the number of things that I want to fill in, is this right here. And the fill value, I'm going to use a compose tangent. And compose tangent will create a hard tangent, which I can pipe into tangents here. So now, when rounding is 0, we get these hard tangents. And when it's a rounding value, they're nice and soft. So this right here, I'll say is hard tangents. And let's just go from here. Okay, so last step would be, let's call this handle spline. Let's call this door handle sweep. Let's call this handle profile. And let's call this handle path spline, let's say. So there you go. You now have your own custom door handle that you can adjust. And we've gone in and we've done a bit of extra work, right? We've cleaned it up so that, in our extreme values, we still get something that looks nice by removing duplicates and by manually setting hard tangents. You don't need to do these steps. Again, for production work, for the most part, this is fine. But if you plan on redistributing, these are the sorts of extra steps, the extra sort of gotchas that you should look out for as you're trying to create a seamless experience for your capsules user. Okay, I hope that you found this interesting, and you can start to see the sorts of applications you would use for your own projects. As you can see, I'm using these in this door setup over here, and this might make its way into the Maxon Capsules collection at some point in the future. Okay, thanks. Have a good one. Bye-bye.